Okay, so now we're going to talk about geometric sequences and series in particular. And again, this is probably familiar to you from last year. A geometric sequence, for example, 2, 6, 18, 54, etc., is a geometric sequence, right? Each term is created by multiplying the previous term by a constant multiple, which is called r. In this case, r is 3. You should be able to write a formula for this. Okay. You might notice that this is 2, this is 2 times 3, this is 2 times 3 squared. So if this is n equals 1, n equals 2, n equals 3, n equals 4, in each one of these cases, the exponent is 1 less than n. So we use this formula a lot. All right, so we say the nth term is the first term times r to the n minus 1. In this case, in my example, an, we start with 2, and then we multiply by 3 to the n minus 1. This is very standard for a geometric series, or geometric sequence. You'll see a constant here, and a constant here. And probably an n minus 1 here, although that can vary. So we're interested usually in the sum, and we're going to start with a finite series, and then we'll try to generalize that to an infinite series. So in pre-calc, you probably did this, although it's kind of fun, so we'll do it again. So if you want to find Sn, the nth partial sum, you want to add up the first n terms. So I wrote some of that out for you. So this is the first n terms. N equals 1, n equals 2, n equals 3, all the way up to n. So the trick goes like this. You multiply both sides by r. So that's going to be r times Sn. Let me get rid of this. This turns into a1 times r. This becomes a1 times r squared. This is a1 r cubed. I think I'll put the dot in. My last term is going to be a1 times r to the n. I even might stick in the next to last term, a1 times r to the n minus 1. That's the nice thing about the dot. You can put in as many terms as you like or leave them out. So the next thing we do is we're going to subtract. So we're going to do that top line minus the bottom line. So on the left, I get Sn minus Rsn. What happens on the right? So I'm going to do this top line minus this bottom line, and a lot's going to cancel. So this a1 plus r cancels with this a1 plus r. a1r squared cancels with a1r squared, etc., etc. Even this guy is going to cancel out with this guy. So what's left? The only thing that's left is this a1 up here and this a1 plus rn down here. And I'm subtracting. Okay. I can factor out an a1. So I'm going to solve for Sn. That's my whole plan. So on the left, I can factor out an Sn. Right side stays the same. And solve for Sn by dividing. So Sn equals a1, 1 minus r to the n, over 1 minus r. And this may be a formula you know from pre-calc. This is the sum of a geometric series. It's the sum of the first n terms, right? Now, that's great for pre-calc. But we in calculus want to go further than that. We want to talk about infinite series. So here we've got our formula, and realize that this is our formula for our nth partial sum. Okay? Oh, that was good music. I think we have a bonus song coming up for you. This is our nth partial sum. And to find our infinite sum, we have to say what happens as n is going to infinity. So let's think about that, right? How do we do this? Right? I don't even know if this limit is going to exist. Okay? Lots of these things are constants. A1 is constant. R is constant. In fact, the only thing that's varying, I think, is r to the n. So let's look at that. So what happens with r to the n as n is going to infinity? So what happens here? R to a really big number. Does that exist? Usually, something like 3 to a really big number goes to infinity. Right? 4 to a really big number goes to infinity. Even -2 to a really big number is definitely not going to exist. Okay? But there is one situation where it does exist, which is if this is a fraction, something like 1/2. Because if you take 1/2 to a really big number, that's 1/2 times 1/2 times 1/2 times 1/2 times 1/2. That doesn't get bigger. It gets smaller. It gets closer to 0. Okay? And in fact, this is always going to happen when your r is a fraction. Okay? More specifically, if r is a number between 1 and -1, then the limit as n approaches infinity of r to the n is going to equal 0. So in this situation, this goes to 0, and the whole thing becomes a1 over 1 minus r. And this is your formula. So this is your formula for the sum of an infinite geometric series. Please note that it only exists when r is between -1 and 1, and that's important. Oh, first a caution. So here's the caution. I have learned that people get messed up with this a1, so I often actually just write it like this, and I tell people to remember that a is just the first term in your series. It's the first term you're adding up. So you don't really have to work too hard at this. A is just the first term that you're adding up. R is the constant multiple. Okay, so that's what I really want you to know. And basically, this is our first convergence test. So the question is going to be, does this series converge? And this is going to be our test. If you have a geometric series and the absolute value of r is less than 1, that's what this says, then you know that that geometric series is going to converge. That's a test. It's called the geometric series test. We're going to have 10 of these tests. This is the easy one.